Okay, so as I said here, titration method, when you see the color changes here, just know that a salt and water has been formed. Then it shows that the reaction has ended. Then you stop. Then you crystallize. You have to crystallize the what? This salt that is formed here. Okay, so that crystallization, it follows. Here there is no filtration. There is no filtration here. You don't filter it because there are no excess. There is no any reagent which is in excess. Okay, there is only salt and water. So it has to start from here. You evaporate to remove the what? The water, so that you remain with the what? The salt. So evaporate. Then when the solution reaches saturation, you cool it so that crystals begin to do what? To form. Okay, so both this neutralization method or titration method and the single displacement method, they use crystallization. Okay, yeah, so don't forget on that. Therefore, let's move on the other method that we can use to prepare soluble salts. Okay, another one is this. For instance, if I say from this reactivity series, if I say copper plus HCl, if I say copper plus HCl or any other acid, do you think this reaction can proceed? Do you think this copper can displace hydrogen following the reactivity series here? Look at where hydrogen is. Look at where copper is. Have you seen it? Can this copper really displace hydrogen ion in the acid here? No. So this reaction cannot take place. So again, we can say these non-reactive metals, you cannot add them directly into acid because no reaction will take place. They don't react. They don't react because they cannot displace hydrogen in the acid, whichever acid you are going to use. Okay? So here also you have to use this indirectly. You add them into acid indirectly by using their basic oxides. Basic oxides, basic oxides. We said, for example, copper oxide is a basic oxide, plus an acid. So here, let me just write it. You say basic oxide plus acid will give us what? The salt plus the water. Or you can just say base plus the acid will give us salt plus water. When you say base, we are talking about those bases that do not dissolve in water. Because those that dissolve in water, they are called what? They are called the alkalis. But those that do not dissolve in water, we call them bases, or basic oxides, or basic hydroxides. Okay, so basic oxide plus acid will form salt plus what? Water. Have you seen that? So here, the next step is giving you an example of like copper oxide. You don't put copper direct into acid because the reaction will not take place because copper cannot displace hydrogen in that acid. So I'll use sulfuric acid this time. Okay? Like copper oxide plus sulfuric acid. Here, it is now the hydrogen that is going to displace copper from copper oxide. Have you seen? Hydrogen is higher in the reactivity series, so it will displace copper in that compound where it is. Have you seen it? So hydrogen ions will displace what? Copper from copper oxide. And then when copper is displaced now, it will react with the sulfate, forming copper 2 sulfate plus water. Because the hydrogen, when it displaces copper, it will react with oxygen to form the water. Have you seen that? So here, you react the acid with the basic oxides of these unreacted metals. Then you have your what? Your soluble salt. All these salts are soluble. That is, this one, copper sulfate, whatever salt you produce here is soluble. Copper sulfate, here we talked of magnesium chloride, here we talked of sodium chloride, all these are soluble salts. So all soluble salts are collected in solid form by the process of crystallization. So this one, it has to undergo the process of what? Crystallization. Of course, this acid, for it to finish, you have to use excess what? Copper oxide. So use excess copper oxide here so that the acid, which is sulfuric acid, will be used up, all of it will be used up when it forms copper sulfate. So which means when you react them in this, put excess what? Copper oxide, copper 2 oxide, okay, in terms of moles. So this one must be in excess, this one must be a limiting reagent, so that whatever will be formed here will be free from sulfuric acid. We will not have any amount of sulfuric acid that will remain here. No wonder we put excess copper oxide, so that it uses up all the acid that is available, so that you remain with a salt that is acid-free. Okay? So the excess copper oxide, you do what? You filter it, like here. Okay? What will remain as a residue this time is excess copper oxide. Then the filtrate will be copper 2 sulfate. Then you go to the next stage. Then crystallization will correct the salt, just like that. Okay? So that's how we prepare salts using this method. However, there's another method. The last one is for carbonates. You know that property of acids, of metal carbonates, which says a metal carbonate plus acid, it will form a salt plus carbon dioxide plus water. Remember that that chemical reaction, I say, is the only one that produces 3 products, like salt, carbon dioxide, and water. Okay, this one, you can use it for any metal. It doesn't select. You can use it for any metal, meaning that the metal carbonate that you use, it can be copper carbonate, silver carbonate, gold carbonate, it can be zinc carbonate, iron carbonate, tin carbonate, lead carbonate, it can be aluminium carbonate, magnesium carbonate, calcium carbonate, sodium carbonate, potassium carbonate. So long any carbonate, you add it with acid. For instance, I will start with the calcium carbonate here, plus maybe nitric acid. Nitric acid. What salt are we going to form here? The calcium is going to displace this hydrogen and it will combine with what? Nitrate. So we shall have calcium nitrate plus carbon dioxide plus what? Water. You just balance the equation there. It's you writing an exam. It's not me. Balance it. Okay? Yeah. So you can see the salt that were formed is this one. It's another soluble salt. So this one, always a carbonate is in excess to use up the acid, so that no acid should remain in this salt. So always this, anything you react with an acid must be in excess, so that all the acid that you are using must be used up and the salt you produce will be acid-free. This gas will escape, then this one you will remove through this process here that you are seeing, okay, through evaporation. Then it goes further by cooling, it will form crystals of calcium nitrate. Those are the 4 methods that you can use to prepare the what? The soluble salts. Okay, so we have, I encourage you to always start with this one, this one here in the middle, so that it will give you a reason why this cannot be used here. Also, this cannot be used here. Then the last one is this one that caters for everything. Otherwise, these are the methods. Number one, to summarize them, I can bring another paper to summarize them. That preparation of soluble salts. Preparation of soluble salts, as you can see, is metal plus acid will give you salt plus what? Hydrogen. Then alkali plus acid will give you salt plus what? Water. Then basic oxide plus acid will give you what? Salt plus what? Water. I'll send you these notes here. Okay? You copy, and as you are answering your assignments, use the same notes. Then here we have metal carbonate plus acid will give us salt plus carbon dioxide plus what? Water. So these are the examples that are given. That's a summary on how you can use these. They are A, B, C, D. All right? Okay? Enjoy your assignment.